Hi, everybody. Oh, I'm shorter than these guys. I'm going to preface this with I'm probably going to skip a whole bunch of slides because we have gone a little over time, and apologies again. We're so Canadian, just apologizing over and over and over again. But for the students, I will also be doing the program session later today so we can cover off extra stuff, and I'm here all day if you have questions. So we'll just fly through this as quickly as possible. So I'm Devin Hutchinson. I'm the academic advisor for first-year students that are registered on main campus in the Honors Arts and Business program. The main difference between high school and university is that the teachers know you, they know each other, they're talking about you in the staff room, and so, if things come up and you miss things, they'll be like, well, Jane, it's okay, just hand this in later. That doesn't happen here at university. So that's a really big kind of transition for students to recognize sometimes your profs may not know who you are, and it's really important that you're really open and honest if you're struggling, asking for help. If there's one thing you're going to take away from this session, ask for help. And moms and dads, you're in the crowd with your students right now. Sometimes you might be aware before anybody on the campus is that your student is struggling, and so we want you to be partners in your student's success, in that, when you're talking to your student on the phone and you're feeling like things maybe aren't going well, then encourage them to reach out for all the resources that are on campus to make sure that they get some support. So that's kind of like the biggest thing. 90% of you are going to be on your own for the very first time. You are not in class all day, every day, the way that you are in high school, so there's tons of freedom, which is awesome, but sometimes students struggle with a good balance. Most of the time when I'm talking to students, it's the ones that are struggling. And so again, the key thing is just figuring out that balance and making sure that you're being responsible and taking care of yourself, and making sure that when things start to go wrong, you're starting to ask for help as soon as things maybe are struggling, you start to struggle. You guys are the best students in Ontario. So we have the highest admission standards of any Faculty of Arts in the province. So all of you are awesome in high school. I already know that. That can be a really big challenge for a lot of you, in that you may find you're struggling for the very first time in your life here. So don't disregard the tips that you're going to pick up today, and don't think, oh, that'll never happen to me, because it could. And if you do start to struggle, you want to know where to go to get support. I'm going to skip that one. The main thing is, the term is 16 weeks long. That's it. The entire semester is 16 weeks. So when you start to fall behind, you're going to start to fall behind really, really, really quickly. And you will have moments where you're like, oh my goodness, there's so much to do and I don't know how to stay on top of things. So I'm going to cover a couple little tips. One of them being, do the textbook reading before you come to class. What that does is it helps prepare your brain with categories of stuff that you've read in the textbook to then more easily receive the information that the prof is sharing with you in the class. So if you can, get that textbook reading done ahead of time. For most of you, you're only going to be sitting in class like this for about 15 hours a week. So students are like, oh my God, I have so much free time. I can do like everything I want to do. You should be doing, at the very least, another 20 hours of work outside of when you're sitting in class. And so part of what you need to be doing there is reading those textbooks ahead of time. In terms of making a smaller classroom, a larger classroom feel smaller, all of you sitting in the front row, give each other all a high five. I mean it. Let's get to know each other. Sitting in the front row. So this theater holds about 650 people. And don't you feel like we're really connecting, guys, in the front row? Don't you feel it? I feel it. So sitting in the front means you're not distracted by what's happening in the back, and you can get to know your instructor. Your instructor will know you a little bit better, so if you have to go and speak to your instructor, your professor, and are like, oh, I really don't understand this one concept, they're going to be like, yes, I've seen you sitting in the front row. I know that you are someone that's been showing up to class, so I'm going to put in a little extra effort and help you through what you're not understanding. So sitting in the front row is always a really good thing, and it helps to avoid distractions. Some people go to class and bring their laptop and then watch movies or on Facebook, which you know, you guys, you're paying like a lot of money to sit in class, so go to class and be focused. Sitting in the front row, if someone's doing something foolish, like watching a movie or being on Facebook during class, you're also not gonna see those distractions on the screens in front of you. So way to go, front row. The rest of you are okay too. Maybe you didn't know. Now you know, okay? So stuff's gonna happen. You're gonna struggle. The key is building that resilience to push through those struggles, and this is the asking for help part. So when things start to happen, there's lots of different resources that you can go to. Your TAs and instructors are the best people to go to when you don't understand something in class. Most people don't want to do it because they're afraid of looking dumb. You're at university, you're learning. Of course you don't understand everything. So going to them and asking for clarification is a great thing to do. It's not gonna make you look dumb. When other things are happening, if you're facing like an academic emergency, like you're missing an exam or a test, the sooner you talk to people about your struggles, the better. Because if you approach someone asking for help after something has passed, your options are much more limited. As advisors, so I'm one of many advisors that you would be able to speak to, we are sometimes more available than professors because we're on campus all day, every weekday. I often say to students, if you're like, stuff's happening and it doesn't feel good, but I don't even know what questions to ask, come to me. I know what questions to ask you to figure out what the real challenges are, and you can come and talk to me at any time. I have people that cry in my office. I have people that swear in my office. There's no judgment whatsoever. I do some swearing too sometimes, just to be honest. There's no judgment at all from any advisor. Whatever you're struggling with, we're here to support you. If your struggles are bigger than what I can help you with, I will walk you over to counseling services. I will liaise you with somebody that can help you in finance, but we are a great place to start if you're really struggling. So moms and dads, if you feel like your student is struggling and they don't know where to go, just say, go see Devo. Go see your academic advisor. And we'll kind of handhold them to figure out where they can get support moving forward. So finding that balance, I talked a little bit about it before. This experience should also be fun, right? And sometimes when you're taking breaks, you know, from studying and you're going out and making sure that you're making really good, positive relationships with new friends, that is really good for you as well. So finding the balance is really, really important. You're gonna learn what works and often what doesn't. So sometimes you'll try something and be like, oh, I failed an exam for the first time ever. I guess Devo was right, and I should be going to class every single day. But that's part of the experience, right? So the big thing is that resilience, asking for help when you need it, really understanding right from the get-go, things are not feeling good, and asking for help right away. That's the big main thing. Whew, that was quick. What question? 10:04? Yes! Yes! Okay, do we have time for questions? Okay, a couple of questions. Don't be shy. Come on, people. Front row, anyone? See, they know what's going on because they're in the front row. Yes.
So let's say you're not in art classes or on English, no payment in your academic.
Yes.
Does that mean that we're not allowed to like?
Come and see me. What program are you in? I'm just kidding. So anybody that's in AFM, SDS, or Global Business and Digital Arts, you guys have a different advisor. So short answer, because sometimes people are like, well, you're so great and funny. I'm like, I know. So people want to come and talk to me. Of course you can. The Arts Undergraduate Office is open to anybody. Technically, though, what I usually say to students is you want to make a connection with your advisor, because when it comes down to it, if you're struggling, and you've been coming to talk to me, and then at the end of the term, they're like, whoa, these grades are not they'll have no idea what's been going on with you. It really helps your advisor as well as you to make that connection early on. But if you're struggling, and especially GBDA students, you're not on campus, you're not in Stratford all the time, the Arts Undergraduate Office is a great place to stop. Our front desk staff is also amazing, so sometimes you don't even need to see an advisor. They'll be able to answer questions for you. What other questions do you have? Really? I was that good, guys? Really? I know. Okay, we're short for time, so I will wrap it up. So parents and students, you're going to separate. So in the interest of time, maybe, okay, everybody rise. When I say so, don't do it yet. And so parents, you're gonna go back out into the hub and you're going to be guided by a couple different people over to Fed Hall where your parent session begins. Students, you guys are gonna be in this room, but probably everyone needs to get up to let everybody out. So students, come right back into this room. If you need to take a comfort break or a bio break, do so. And then students, when you come back, I want you to squeeze in. I didn't say rise, people, but go ahead.
I'm going to say a little bit more about myself. So like I said, I'm a PhD student here in philosophy. I started my undergraduate career at the University of Western Ontario, and I graduated from business school there. I came to Waterloo to do my master's in philosophy after doing business school, and I work on business ethics, and then I started doing my PhD. I started working with the Student Success Office last year, teaching some of the first year skills classes that the Student Success Office runs and running programs like these. And I'll let Paul say a couple words about himself.
All right, everyone, thank you. All right, my name is Paul Ware, and I'm a lecturer in the psychology department. So that means I'm a faculty, but I primarily do teaching as opposed to research. I did my graduate degree at the University of British Columbia in the area of evolutionary psychology, and I look forward to telling you some things about memory today.
So as we go through this first part of Paul's lecture, think about what kinds of things you might want to do before class. So these are some of the things that you might want to do before class to be as prepared as possible to come to each of your lectures. You might want to pre-read your course material, take detailed notes during class, review your notes from class every night, or review your notes from class from the previous class before you come to your next one. Think about how much time you actually spend studying for tests in high school, and think about how that might be different given that you have this 80-20 split in your time when you come to university. And then think about submitting coursework and assignment on time. So that's one of the big differences between high school and university is there's very little lenience in how much leeway you have in getting your assignments and exams written on time. So keep these things in mind as we go through Paul's lecture, and we will stop him in the middle of the lecture to give you some notes, some tips on note taking. So you all have your notebooks that you got this morning. If you want to start taking notes the way that you normally would in class, and then we'll work with those as we go through the presentation.
Okay, everyone, if I can ask you to direct your attention up here. One more thing I wanted to tell you about, something interesting about myself outside of the school, because we're not just about work, we're also about life, right? So I have a little boy, his name is Lucas. He turned 8 on Friday, so we're all pretty excited about that, especially him. A lot of people think that I named him Lucas because I grew up with Star Wars, I was a Star Wars fan, but that's ridiculous. I'd never name my son after a movie character. He's actually named after the cat. Okay, so I'm going to be talking today about memory. This is always the first topic that I cover in Introductory to Psychology. If you take Introductory to Psychology, I might be your professor. I'm one of the 2 instructors who teaches that class. And why would I choose memory first? Any ideas? You want to offer a suggestion about why this should be such an important topic to occur early as opposed to late? Yes?
Because it will help us with the rest of the course and hopefully help us remember the topic.
That's exactly right. So the idea is to educate you a little bit about what memory is, how it works, so that you can use it as a tool to work for you throughout the rest of your university career. Okay? A lot of students think that they don't have a good memory, but in fact, the reason is they think that is because they haven't exercised their memory. Right? Memory is a skill. It's something that gets better the more that you use it. In high school, it doesn't really emphasize a lot of memory work anymore. So memory work is important in university. It is the first step in learning, not the last step. That's important to remember as well. Okay? All right, so we have a couple of questions here to help guide the discussion. First of all, how do we conceptualize memory in psychology? Right? So there's a particular way that we think about memory in psychology that might not be entirely intuitive. Secondly, what are the different processes of memory? So memory is not a single process, it's actually a collection of processes that work together. Third, how can we encode information to make it more memorable? In other words, what sorts of things can we do to help improve the different types of memory storage? There's actually 3 different types of memory. We'll outline what they are, and then we'll take a closer look at one of those types, specifically short-term memory, otherwise known currently as working memory. And so the final question is, what are the different components of working memory? How does it work? Again, understanding that can help you in your university education. Okay. All right, so first off, what is memory? It's important to recognize that memory is a reconstructive process. So think about what happened over the weekend. Right? When you do that, it probably doesn't progress like film. You don't think about, oh, well, I remember waking up, and then I did this, and then I did that, and then I went to the bar, and I watched France beat Croatia, and then I did some other things, and so on and so forth, right? It's probably just fragments. You pull out little bits and pieces, and you put them together, and you reconstruct all of the details associated with those individual memories. And each time you do that, you're creating it from scratch, right? So it's reconstructed every single time. Now, what that means is that memory is riddled with errors, because every time you reconstruct it, you change it just a little bit. Sometimes you add a detail that actually never happened, maybe borrowed from a different memory. Or you change some of the details. Yes? Videotaping the neat sound. Oh, okay. All right, apparently I'm being forced to use the microphone. Because they're videotaping and they can't hear me unless I'm using the microphone. Okay. Oh, right. Okay, so what was I saying? I can't remember. Changes in details. Good point, right. So sometimes you add a detail that actually wasn't there in the first place, or you change it to a different detail, right? A red shirt becomes a blue shirt. Or sometimes details are lost, right? They're forgotten and they disappear. You can have entire memories that never actually happened, okay? All right, now what this means, that's a very interesting consequence. What this means is that the memories that you use the most are the least accurate. The memories that you rehearse and practice the most have more errors than other types of memories. Okay? Now, I should mention that we're talking about a particular type of memory. That's episodic memory. That's memory of events, right? Your childhood, what happened last Christmas holidays, and so on and so forth. When it comes to facts, right, then the more that you rehearse, right, because you're double checking those facts, right, then you're correcting errors and so on and so forth. So that's fine. But when you rehearse episodic memory, you're introducing new mistakes in it all the time. Okay, so there are 3 different processes associated with memory. The first one is encoding. This refers to the process of entering information into memory. This is similar to typing information on your keyboard into your computer. We also have memory storage. That is the maintenance of the information once it actually arrives inside a memory. So this is very similar to the hard disk, and in some cases the random access memory that is located within your computer. And then finally we have a process of retrieval, sometimes called recall, where you bring the information back into memory so that you can use it in some productive way. So this is like calling up a file that you finished and it appears on the screen so that you can look at it. Now, it's not exactly like a computer, right? So the computer metaphor here is useful, but it's not exactly the same because, of course, when you save your essay and then you shut down your computer and you turn on your computer and you bring up your essay, it's always the same essay. It's exactly the way you left it. But remember that memory is reconstructive, and so when you bring it up again, it actually changes, right? And often you don't even realize that. Okay, so those are the 3 processes associated with memory. What is forgetting? Well, it's a deficiency in one or more of those processes, right? So if you don't encode the information, you forgot it. If you encoded it but you don't store it, you forgot it. If you encode it and you store it but you can't retrieve it, then you forgot it. Okay, so we're going to take a closer look at encoding to begin our topic today. We have 2 different types of encoding. We have something called passive encoding. In this case, simple information can be encoded automatically with no effort on your behalf whatsoever. So for instance, where you parked your car, right? So when you park your car, you don't pull out a little map and then circle the intersection at which you parked the car, right? You just sort of take a mental note and then you go back to your car, right? Sometimes you forget, but usually you don't, okay? Last night's TV show. All right, so did anybody watch, who watched TV last night? Yes, which television show did you watch? Family Guy. What happened? You don't remember. You don't remember anything that happened. Okay, bad example. It was because of passive encoding, though. All right, somebody else want to play? Yes? Yeah. Agents of S.H.I.E.L.D. Okay, great. And what happened? Just briefly, a synopsis. A couple details about the show. Great, great. So they found an alien device and the plane blew up on their way home. Okay, did you have to check your notes before you answered that question? Were you making notes about the television show as you were watching it in case I asked you about it today? No, because you're using passive encoding, okay? All right, also word frequencies is another example of passive encoding. So what is more common? Which word is used more commonly? Elephant or pachyderm? Do you know what a pachyderm is? It's an elephant. All right? So the concept is equal in frequency, but the words might differ in frequency. Which one is used more frequently? Elephant. How many people think elephant is used more frequently? Yeah, of course it is. But how do you know that? Were you taking stock every time somebody said elephant, check mark, elephant, elephant, ooh, pachyderm, elephant. No, you just sort of know it's passive encoding. Okay. All right, so we have passive encoding, and then we also have active encoding. Here, what we have is more complex information that requires effort on your part in order to be able to remember it. And so this is, when we mean complex information, we're talking about things like course content, lecture content, content in your textbook. If you're simply going to lectures and listening, maybe you'll get a little bit of information out of that because you're using passive encoding. You don't forget everything necessarily, but you won't remember enough in order to be successful at university. You have to invest effort. Okay, now given that you have to invest effort, there's two different varieties of active encoding, at least as applied to learning. The first one is called massed practice. Here, learning proceeds over one long session. So example, cramming for the test the night before, right? 6 hours of nonstop studying, trying to buckle down those concepts in order to be prepared for the test the next day. All right. The other type is called spaced practice. Here, learning is broken up into a number of short sessions over a much longer period of time. So maybe 3 nights before the test, you have 1 hour sessions twice a day, right? And then you're preparing. So same 6 hours, right? But it's distributed over several days, 1 hour units at a time. Which of those do you think is more successful in terms of getting better grades and understanding the information better? Yes? How many people think it's spaced practice is the better? Does anybody think that mass practice is better? It's not. Spaced practice is better, right? Spaced practice is, and students intuitively know this, right? You know that spaced practice is better. Which one do you think most students use? Yeah? Mass practice. That's right. They know what's good for them, and they do the other thing anyway. And often it's because they get behind the ball, and they're trying to catch up, right? So don't get behind in your courses, right? Stay up to date. Okay, in particular, they tend to use mass practice the more difficult the information is, right? So the stronger the payoff for spaced practice with really difficult information, the less likely they are to actually use it. Okay, so we're going to be moving on with active encoding here. Whether it's spaced or massed is irrelevant at this point. We're going to talk about a famous experiment conducted in memory by Craig and Tulving from the University of Toronto. This one was published in 1975. We're not talking about them because they're from the University of Toronto. They're actually world-famous researchers. This is one of their most famous experiments. What they're looking at is how different levels of processing can enhance memory retrieval later on. And so what they did is they collected, or they organized a series of different types of encoding that vary in terms of their depth. So you can have a shallow level of processing. An example of that would be something called structural encoding. So encoding is entering information into memory, right? And here what you're doing is you're emphasizing the physical characteristics of the stimulus, right? The structure of it. Firstly, you can have a deep level of processing, such as semantic encoding, which is a really important form of encoding. And here, you're emphasizing the meaning of the stimulus, right? So semantic means meaning, okay? And in between that, you can have intermediate levels of processing, for example, phonemic encoding, where you're emphasizing the sound of the stimulus, right? Phoneme refers to sound, okay? All right, so what they want to do is they want to control for the way that people handle this information and respond. Otherwise, you observe differences between these different conditions, and it could be some reason other than the depth and the level of processing. So what they did is they asked them questions focusing on one of these 3 different types of encoding, and then asked them to respond with a yes or no answer. So for instance, is the word written in capital letters, right? So they would flash a word. Let's say the word is hippocampus, okay? And it's all in lowercase. And they ask you, is the word written in capital letters? You would say it louder. Say it like you're angry. Okay, good. Well, not that great. Let's do it one more time. Really angry. No! Okay, thank you. All right, so, they might give you the same word, but this time they ask you, does the word rhyme with weight? Remember, the word is hippocampus, right? Does the word rhyme with weight? And you would answer, come on. Put some energy into it. Does it? Okay, thank you. All right. Or they might ask you a question that focuses on the semantics, right? So, would the word fit in the sentence, he met a hippocampus on the street? You would say, no, you can't meet a hippocampus on the street. All right, so notice that in all 3 conditions, they're asking you a different question. The stimulus is the same. Your response is exactly the same, all right? And they give you a whole list of words that they're going to present in this way. So there could be like 30, 40, 50 words. And then you go away, you come back later, and then they ask you whether or not they test your memory of the words. So what they do is they present some new words, and they ask you, did you see this word before or not? And sometimes they'll present you with hippocampus, and they'll say, did you see this word or not, right? So if you see hippocampus, you're supposed to say, yes, I remember that word. And if you see some other word, then you say, no, that word was not studied, okay? All right, so what are the results of the study? So here we can see, in terms of structural encoding, we're just asking about the physical characteristics. Was the word written in capital letters? Well, there's less than a 20% chance that they remembered the word when they were asked about the physical characteristics. When they asked about the word rhyming with weight, right, phonemic encoding, now they remembered about 50%. So it's a deeper level processing, right? They're more accurate in their memory. When they ask them about the meaning of the word, does it fit in the sentence, he met a hippocampus on the street, even though the answer is no, then it's about 80%, okay? 80%. All right, so we have active forms of encoding. Focusing on structural encoding gives you the best memory performance, but you can do even better. So we can enrich semantic encoding to make it better. One way that you can do that, and this is not the only way, but one way is through self-referent encoding. What's the most important thing in this world? It's me. Well, to me, it's me. To you, it's you. Right? You're the most important thing in your world. So things that relate directly to you are more memorable than things that don't relate to you. All right, so for example, think about your birthday. Can you think of a famous person, either real, well, of course they'd be real, but a famous celebrity or a famous historical person who was born on the same date? How many people can think of a famous person who was born on the same date that they were? Okay, a few people, not that many. I'm a little disappointed, but that's okay. All right, now think about your best friends and their birthday. Can you think of any famous people born on their birthday? How many people can do that? Fewer people, okay? A couple people. Congratulations, you must really like your best friend. All right, so that's an example of self-referent encoding. So Rogers, Cooper, and Kirker in 1977, what they did is they replicated the Craik-Tulving experiment in 1975, exactly the same experiment, but used a new list of words. All the words were adjectives instead of nouns, okay? Adjectives. And they asked them about structural encoding. They asked them about phonemic encoding questions, they asked them the semantic encoding questions, they replicated approximately the same data results, and they asked them in another condition, does this word describe you as a person? And they would have to say either yes, the word does, or no, the word does not. And then again, tested their memory later, and what they found was even better memory recall, okay? So you're not only focusing on the semantics of the word, but you're also applying it to yourself. So any information you apply to yourself, you see better memory performance. Okay. So, memory quiz. What I'm going to do is I'm going to flash a sequence of 12 letters. I'm going to give you about 10 seconds to study them. Don't write anything down yet, and then I'm going to remove them, and then you try to write down as many as you can in the proper order. The order matters. Okay? And this is an individual exercise, right? So don't cheat by working together. All right? Okay, are you ready? Are you ready? Okay, good. Okay, again, you got about 10 seconds. Okay, write down as many as you can in the correct order. All right, still see a few people working away. Looks like most people are done. Okay, so here you go ahead to check your results, see how many you got correct, right? Correct letters in the correct order. All right, how many people got at least the first 5? At least the first 5. Okay, good. How many people got at least the first 9 correct? And who got all 12 correct? All right, so quite a few people. Wow, you guys must have amazing memories, right? All right, how did you do it? How were you able to remember 12 pieces of information all correctly? Yes?
I separated them into 3 sections. So like I did Fed, PhD, CRC, and then IBM.
SRC and IBM. Yes. Okay. So what she did, she broke them down into groups of 3, something like that, right? That's right. So if we look at this stimulus, right, what we have here is 12 pieces of information unconnected to each other, very little meaning except that they're letters, right? And that's a challenging task to try to remember all that information. What we have here is 4 pieces of information that actually has some meaning to you, right? Fed, referring to the Federation of Students, which you are soon to be members of at this university. PhD, a higher degree, right, earned at university. SLC, the Student Life Center. Many of you will be spending lots of your time there over the next 4 years. And IBM, a famous corporation. Okay, yes, question? Oh, was it? I forgot to switch it. Yeah, okay, it was also a trick. Yeah, sorry, thanks for pointing that out. I'll have to fix the slide for next time. Okay. Okay, so, all right, this is called chunking. Trust me, this is called chunking. There we are. That is, combining elements of information in order to create fewer but more meaningful chunks of information. Okay? And this can help you dramatically improve your memory process, especially when you're trying to track a lot of information, right? You connect it through chunking. Okay, so mnemonics, some mnemonics, they use chunking. A lot of mnemonics. Mnemonics are strategies that you can use in order to improve your memory, little tricks or strategies. Some of them utilize chunking, but not all of them. So some examples include the notes that are observed on musical script, right? So if you are a student of an instrument that uses the treble clef, right, you have to memorize the names of the notes that correspond to the lines and also to the spaces. The spaces are a little bit easier because they represent F, A, C, and E, right? They spell a word that's meaningful, face, right? But the ones for the letters are a little more difficult, right? And that's E, G, B, D, and F. And what's the mnemonic that almost all students use in order to remember those notes? Yeah. Every good boy deserves fudge, right? So that's a mnemonic that helps you to remember the information, but it's previously unconnected information. What's the letter before J in the alphabet? At the back, yeah? I. And how did you solve that question? You sang the alphabet song, didn't you? That's right. The alphabet song is a mnemonic, right? Its purpose is to help little kids learn and remember the alphabet, okay? All right, so I think we're going to take a break here, and I'll be back in a little bit, but I'll pass it over to Vanessa. There you go.
Okay, so you've gone through the first half sort of Paul's lecture. I want you to think about what you could have done before the lecture to make that material more meaningful to you. So could you have previewed the lecture slides? If you looked at the lecture slides beforehand, you would already have a framework or a skeleton of what Paul was going to talk about, and then you would know what to expect coming into your class. If you reviewed your notes from last class, you would probably know, or if you looked at your syllabus, you would probably know that we were going to be talking about memory today, and that would have pointed you to certain readings or course material that you might have had to know or have done before class to have prepared for class. I will emphasize that you should plan to attend all of your classes. You get a lot of material out of the lectures itself, so even if you do all of the readings and look at the lecture slides online, you will still be missing information if you don't come to class. And then, like I just said, you want to read all the textbook materials and prep work before you come to class. This is really important because today's lecture is a little slower because we know that you didn't do any pre-reading. But if Paul had assigned you pre-reading, let's say you had to read the memory chapter in your textbook before today's class, he might go a little bit quicker through the material because he might say, oh, this was emphasized in your textbook, we can skip past this a little quicker. That doesn't mean that information isn't important, it just means that because it's in a different medium, they might not spend as much time during class teaching you that material. So you are responsible for learning that material yourself. So given that there's all this prep work that you have to do, managing your time is something that I want you to start thinking about now before you come in for September. This is something you might want to start doing over the summer to start planning your courses out so that you are prepared and ready to go when you move in. So one thing I will note is that when you first get your course schedule, it's going to look pretty empty. You have 5 classes, maybe 2 times a week each, so that's about 10 hours of your time that's blocked up with classes. The rest of the time is yours to use, and at first that looks really easy, right? It looks like you have all this time to prepare for all these classes and you're gonna be totally fine. What happens is because you have 5 classes to prepare for, we say about 3 to 4 hours of prep work for every hour of class, so that adds up really quickly. So what you end up having to do is to manage your time very carefully so that you manage to do all of your prep work, get your assignments done, get your studying done, and then do all of those life things as well, like laundry, like cooking, like getting groceries, and make sure that you're able to do all of those things for yourself, to take care of yourself properly when you're in first year. So there are a couple of different time management techniques that we're not going to go into today, but there's a lot of information at the Student Success Office if this is something that you're interested in. There are time management workshops that you can sign up for, and there's an online workshop as well that you can access to help you manage your time better for first year. So that was before lecture. Now we're going to talk about what you should do during lecture. In lecture, there are 2 different types of listening you can use. There's passive and there's active. Passive listening is what happens when you just hear what the professor says and you copy it down. So who was sort of doing that with their notes? They just sort of heard what Paul was saying and wrote down what he was saying. A couple of us, right? Active listening is more like carrying on a conversation with your professor. So when you have a conversation with somebody, there are a lot of words that you say that don't have a lot of meaning, and there are a lot of parts of the conversation that aren't as important to remember as others. So active listening is when you key into that type of conversation with your professor, and you only write down what's important. Another thing you'll do when you actively listen is you'll find that you'll start writing summaries. So instead of writing down exactly what the professor says, you're going to summarize a lot of information about chunking, for example, down to maybe 1 or 2 bullet points. And that's going to be the key information that you're going to have to take away, that you're going to be tested on in your tests and your exams. So some note-taking strategies to help you with active listening. Keep all of your notes organized, labeled, and neat. So we've all had this happen where you drop your binder and it opens up and all your notes go everywhere and suddenly they're all mixed up. So you might want to do things like numbering your pages or dating your pages, using different colors for different days if you're more of a visual learner, any kind of strategy to help you keep track of what notes go where. Use descriptive headings. This is really important because when you look at your sheet of notes, it's really intimidating to see just a lot of information all written in the same text size and all not really organized. So use descriptive headings. Use your margins to collect key ideas and keywords. We're going to talk about a note-taking method to do that in just a second. And you want to, again, make these summaries. Summarizing information is what's going to make that information meaningful to you, and that's going to help you remember information for your tests. You can invent your own shorthand or short form, your own abbreviations that you want to use. So because is often shortened to BC, and you can just use the ampersand symbol instead, and you can come up with your own. So as long as the notes make sense to you, they're perfectly fine. There's some debate between laptop and written notes. So who thinks they're going to take notes on a laptop? And who thinks they're going to handwrite their own notes? So why do you think you would use a laptop instead of handwriting your own notes? Yeah.
Personally, for me, I've been using the laptop for a few years because I'm IEP, so it's like anything I can.
Mm-hmm.
So definitely, my handwriting is really
Yep. Anybody else in the back there? Yeah, so it's more detailed, right? You can go back and find all of those little details. How about people who handwrite instead of using laptops? Why would you do that? Yeah. Yep, so it helps you remember information when you write it down yourself. Any other reasons? Yep. Yeah, so that's a great idea when you're color coding your notes and making that information really meaningful to you. So there's mixed evidence on whether laptop notes or handwritten notes are best for remembering information. What all of the research does say is that what's most important is what you do with that information afterwards. So if you have more detailed notes because you've taken them on a laptop, what's important is that you take that detailed note and summarize it into information that makes sense to you and that is easy to digest so that you're not studying off of all of those details because you're not going to be tested on all of every single little detail, right? The important thing about handwritten notes is to make sure that you're getting down all of the main points in whatever messy fashion, whatever abbreviations you need, and then again, making sense of that information by making summaries and making it neat and organized later on. So what's most important is what you do with these notes after, which we're going to talk about in a little bit. So whichever method you choose can be effective, but just keep in mind that you have to process these notes after the fact. So this is one method of note-taking. It's called the Cornell Method. So I want you to flip to a new page in your notebook and divide your page into 3 sections. So you have that line on the left margin, right where it says keywords. You want to put that line down, and then one line across the bottom of your page right above where it says summary. So this is the Cornell method of taking notes. What you do is during the lecture, where it says notes on the right side, right top, that's where you record all of your notes. So you write down information the way you normally would when you're taking notes. What you want to do during the lecture and after the lecture as well is to fill in that left side where it says keywords. That's where you write down key concepts that you know you're going to be tested on or that you know you need to know. And you can also record questions that you have that might not have been answered during the lecture that you can go back to later on. Then after the lecture, at the bottom, there's a summary section, and you're going to write a summary of that page of notes. What does this page of notes mean? So that later on when you're flipping through your notes, you can very quickly find the notes that you need, and the summary portion, again, helps you to process that information. If you don't like the Cornell method, if you think this is too linear for you, another method you could use is called the concept method. This is a really great example of a concept method note-taking map. So what you might find is that some professors tend to jump around in a lot of places, or you might find that you in your own head jump around in a lot of places. This type of note-taking method is going to be really effective for you if that's the case, and if Cornell and your regular note-taking methods haven't been great. So what you do with the concept method is you put the main topic right in the center where it says the Italian Renaissance on this one, and then you're going to branch out into different areas of information that you need to know. You're going to record all of the information you normally would writing down in a linear fashion, but it's going to be organized into a concept map instead. And this helps a lot of people retain information and learn a lot better. You'll see in this concept map, it's color-coded, so you know which section belongs where. There are underlines being used, and there's a system of information that makes that information make sense to the note taker. So if you don't like the Cornell method and you don't like writing down notes in a linear fashion, I encourage you to try this for the rest of Paul's lecture to see if it works for you. There are a lot of other note-taking strategies too. Again, they're all on the Student Success Office website, and if neither the Cornell or the concept method works for you, we can chat about other options as well. So I want you to try using the Cornell method or the concept method for the rest of Paul's lecture and see what kind of notes you end up taking.
Okay, so what we're going to do now is we're going to be moving on to different types of memory storage. And I mentioned that there's 3 types of memory storage, and they are combined together in, sometimes in what's called the 3-box model of memory storage. So each box corresponds to a different type of memory storage. The one we're going to be talking about is the one proposed by Atkinson and Schifrin, but there's many different varieties that are very similar to this. But different in some of the details. But the idea here is that we have 3 functionally distinct memory stores, 3 different memory stores, 3 different functions or purposes, not necessarily associated with distinct anatomical structures, meaning that we don't necessarily point into the brain and say, aha, here's long-term memory, and this part of the brain is visual register, and so on and so forth, okay? Although they do have neurological correlates. Okay, so how does this model work? So we have information that exists in the environment, right? So right now, if you're paying attention, then I'm the information that is entering into from the environment. And the first place that it goes is into the sensory register, all right? Now it's a little bit misleading because there's actually 5 different registers, one for each sensory modality, right? One for vision, one for audition, one for taste, and so on and so forth. Right now, your auditory register and your visual register are probably more active, and your taste register is less so, all right? Okay, so these registers have large capacities, right? They have huge capacity for holding information. In essence, your visual register holds everything that enters through the retina for a fraction of a second, okay? So, in terms of the visual register, it's about a quarter of a second up to half a second, right? There's individual differences between people, and there's variation over time. But a quarter of a second is on average. And then it's dumped and refreshed with a new retinal image, and then dumped and refreshed and dumped and refreshed, and so on and so forth. But the important thing here is that it contains sensory information, which is a high-fidelity, exact copy and complete copy of everything that comes in through the retina. All right, some of that information is transferred to short-term memory, and the rest is dumped, it's forgotten. If it makes it into short-term memory has a limited capacity. It can only hold a few things at a time, far less than the sensory register. So most things get dumped, right? Here we have brief storage of items, but much longer than the sensory register. So up to 30 seconds, more typical is about 20 seconds. Information arrives in short-term memory. If you don't rehearse it, it lasts for about 20 seconds, and then it's dumped, it's forgotten. Short-term memory is also important because it's involved in the conscious processing of information, or what we're going to elaborate on as working memory. So working memory is a more modern approach and term to refer to short-term memory. All right, some of this information, some of it can get transferred to long-term memory. And once it's here, we believe that long-term memory has an unlimited capacity. At least nobody's ever got to the full limit of their long-term memory. So I cannot remember another new thing ever, all right? Maybe I'm tired today and I can't remember anything more today, but then tomorrow I'll be refreshed and I'll be able to remember new things. Other researchers believe that storage is also thought to be permanent. That is, once it gets into long-term memory, it's there forever. Now, that doesn't mean you can always retrieve it, but it's there somewhere, okay? And there's various ways that information can be organized and indexed for you to be able to search through it and to find it and to retrieve it and to be able to use it. Okay, so notice, however, that this arrow is bidirectional, right? So information can go from short-term memory into long-term memory, but information can also go the other way from long-term into short-term. So for example, you're working on your math test, and the math test requires you to use a formula for the circumference of a circle. So you dive into long-term memory, you pull out that formula for the circumference of a circle, you bring it into short-term memory in order to use that formula to solve the problem. Once you've done that, it's dumped from short-term memory as you move on to the next question, but remains in long-term memory. Okay, we have one more arrow here that extends from long-term memory to the transfer between the sensory register and the short-term memory. So one question is, of all the interesting things that are happening in your world that you look at through your retina, how does it determine which ones get passed on to short-term memory? Well, that's attention, right? So what you pay attention to is more likely to enter into short-term memory. Well, what are you going to pay attention to? Well, a lot of that has to do with your past experiences, your expectations, your current goals, and so on and so forth. In other words, it's coming from the long-term memory. Long-term memory, to a degree, determines what you pay attention to, and therefore determines what gets passed from the sensory register into the short-term memory. Okay, so that's briefly a description of the three. What we're going to do now is we're going to focus on the middle box here, short-term memory. Oh, but first, we're going to do a memory test. We're going to test your short-term memory. So what I'm going to do is I'm going to pull up a list of 15 words. I'm going to give you approximately 15 seconds to study the list. Again, don't write anything down until I remove the list, and then you're going to write down as many of those words as you can. The order of the words no longer matters, so they can be recalled in any order that you want. And don't worry about spelling, unless you spell a completely different word. Okay? All right, so are you ready? Are you ready? Yes? Okay. Okay. Again, it's an individual activity. Okay, it looks like most people have exhausted their options here. So let's take a, you're going the wrong way now. Okay, so go ahead, double check your list. Make sure that the ones that you recalled are actually on the list. Again, spelling doesn't matter unless you spelled a completely different word. All right, so how many people recalled at least 5 words? At least 5 words. Okay, looks like just about everybody. All right, what about at least 7 words? Okay, still almost, it looks like almost everybody. How about at least 9 words? Quite a few hands went down. Okay, did anybody remember the whole list of 15 words? A couple people over here. Okay, and a couple of people over there. All right, so this is a short-term memory test, right? So you're given some information, and then briefly, right afterwards, you're required to recall that information, okay? All right, so short-term memory. Remember, this is a limited capacity memory system. That's why I gave you 15 words, because 15 words exceeds the capacity of short-term memory. And it retains information for approximately 20 to 30 seconds. I gave you approximately 20 to 30 seconds in order to do your best to recall the information. And after that, you probably weren't going to recall any other words, at least not without some help. Okay. Now, rehearsal, of course, can extend the duration. This is called inculcation, simply repeating the word or the information over and over and over again, right? So you do this often when you're trying to remember a phone number, right? You look up the number to your dentist, and it's like 555-763-95, 555-763-95, right? And then you dial it, and then you stop repeating it, and of course, it vanishes, right? So that's a short-term memory inculcation task. Okay, so the question is, how do we know that information lasts for about 20 to 30 seconds, or on average about 20 seconds. 30 seconds is the longest. Especially when we can just rehearse information, right? So if I bring you into the laboratory and I give you some information, I say, well, here's 5 words, remember these 5 words. And you're thinking about the 5 words, and 10 seconds later, you're still thinking about the 5 words, and then you're conversing with somebody about the 5 words, and then an hour later, I ask you what were the 5 words, and you tell me, right? Because you can keep rehearsing the information over and over again. So what we want to do is we want to prevent you from rehearsing the information and see how long it lasts. So that's what Peterson and Peterson 1959 did. Again, this is a famous experiment conducted in psychology, memory psychology. So we have our participant here who's waiting to receive some information. They start by looking at a green light. That's telling them, get ready, there's some information coming. And then this time the information is delivered as an auditory stimulus. And so we tell this person CJL 547. The letters CJL, that's the target information. That's the information that they're supposed to remember for as long as they possibly can. And at some point we're going to ask them to recall the information, and they have to say CJL. The number tells them start counting backwards from 547. Right? So they have to think 547, 544, 541, 538, and so on and so forth. By counting backwards out loud so that we know that they're doing it, that prevents them from rehearsing the information. Right? It keeps their working memory busy. All right, so they do that, and we vary the time for which we ask them to count backwards. It could be 3 seconds, it could be 18 seconds, it could be even longer, right? It could be 30 seconds, it could be a minute. And then when the red light turns on, they have to stop counting and they say CJL. What Peterson and Peterson found is that as long as it's less than 20 seconds, they could do it. They could report CJL with a high level of accuracy. Not perfect accuracy, but a high level of accuracy. As you went beyond 20 seconds, accuracy dropped off precipitously. And by 30 seconds, it was gone. People could no longer remember CJL at that point. Okay. Now you might ask, remember that each of these memory stores has a function or a task in order to, that they're specially designed to do. And the question is, well, why is short-term memory so short? Wouldn't it be good if we could just hang on to all information all the time, never forget anything? Well, first of all, that would be incredibly expensive to accomplish, even at, particularly at a neurophysiological level. But secondly, most of the information that we encounter, we only need for a short period of time, right? Your your dentist's phone number is only useful for about 20 to 30 seconds, and then you don't need to look at it. So why invest energy and resources into remembering it for all time? Okay. We also know that we have a limited capacity. Capacity is, as famously demonstrated in another experiment by Miller in 1956, the one actually that you just replicated a few moments ago. He gave them lists of words, approximately 15, 16 words in a list, and asked them to remember as many as they could, and typically they could remember 7 plus or minus 2 items. That is, the vast majority of people remembered between 5 items and 9 items on the list. And very few people were below or above that, and that was replicated here. Most people remember between 7 and 9. Okay, now actually, capacity in short-term memory, according to Cohen, Chen, and Rounder in 2004, is actually much smaller. The reason why we can see higher performance at 7 plus or minus 2 items in Miller is because of chunking, right? People combine words together, so when they remember one, the other one pops up too, right? So how big is it actually? Well, Cowen, Chen, and Router, they prevented people from chunking. It was a very complicated design. But when they did that, then people could only remember 3 to 4 things. That's the capacity of short-term memory. You can remember 3 or 4 things, or work with 3 or 4 things at a time, and that's it. Very limited capacity. Okay, so this brings us to a more contemporary view on short-term memory. Remember Peterson are talking about 1959, right? How do we think about short-term memory today in psychology? Well, we don't really call it short-term memory anymore. We call it working memory. And one reason is because Baddeley, which is the model, the researcher who developed the model that we're going to take a look at here, recognized that short-term memory wasn't just about holding on to things. It's not just about holding information for 20 to 30 seconds, but you actually use it to solve problems and to do lots of other things, like listen to language, to produce language, and so on and so forth. So, Baddeley's model of working memory is composed of 4 modules, or 4 different components. Well, okay, let's take a look at the phonological loop, which is in the top right corner here. So the phonological loop is one of the components in Baddeley's model. It consists of the auditory store, right? So this is the auditory register that maintains auditory or verbal information for a few seconds. And this is activated whenever you are listening to somebody talk to you or you're reading something in a book, right? So in order to understand a sentence, you can't just focus on the exact point in the sentence that you're watching or listening, right? You have to consider the sentence as a whole. And that means that it has to be held in memory. And that's what the auditory store in the phonological loop does. It holds it onto it for a couple seconds so that you can consider passages and information as a whole, right, instead of just pieces. And that's why if somebody has a really long sentence, you often lose your way. You have to go back to the beginning of the sentence and try to remember what it's all about, right? Or break it into chunks, right? That's so that it'll fit inside of your auditory store. But of course, you can also rehearse information over and over again. And so that's what the articulatory loop is, right? So that's the repeating of the phone number over and over and over again in order to keep it inside of the auditory store. So basically, the way we used to think about short-term memory, that fits into the phonological loop in Baddeley's model. But like I said, we can do other things as well. So we can create and manipulate mental images. And that's what the visuospatial sketchpad does in the top right corner in working memory. Okay, so I'll give you an example. Ask everybody to close your eyes for a moment. Okay, keep your hands to yourself. I want you to imagine your car or your parents' car or a car that you had access to. Okay, so create that mental image in your mind. Okay, now make it rotate around in a circle. Now its color is black. Now imagine that it's blue. Now it's red. Right? So all these things that you're doing, and you should have no problem doing these things if you have human memory, you can open your eyes again. That's the visuospatial sketchpad, right? So you can create images, and then you can manipulate them, you can change them, right? And create things that don't actually exist. All right, so another thing that the visuospatial sketchpad is good at doing is about the information relationship between objects, particularly in space, right? So again, close your eyes for a second and think about how close you are to me or close to the stage, right? And how close you are to the back of the room. Which one is closer, right? You don't have to turn around and look. You're probably already creating these relationships spontaneously in the visuospatial sketchpad. Right? Okay, so we have information about objects and their locations. We can create mental images. We can manipulate them. And we can put them together with information from the phonological loop in order to create episodes, or examples of episodic memory. And that occurs in the episodic buffer. So here, we create an episodic experience from visual and auditory or verbal information. So for example, when you're reading a book, right, and it's pure text, do you sometimes spontaneously create a mental image in your mind of what's happening? Of course you do, right? And that's the episodic buffer. It's taking information from the phonological loop, it's creating images in the visuospatial sketchpad, and then manipulating them to make them consistent with the thing that you're reading. Right? So without the episodic buffer, reading would be a less rich experience. Okay, so we have these 3 different components, 3 different modules. Now the problem is that each of these is passive, according to Baddeley. They need to be told what to do. So who's in charge of the 3? And that leads us to the central executive. So the central executive here is another component, and its job is to switch between the tasks, right? So when I'm done this task, I'm done reading my book, and I need to look up the phone number for my dentist, right? So it's the executive, a central executive that determines when that's gonna happen, okay? Oh, forgot, I have to call my dentist, put the book down, switch to a new task. It also deploys attention to each of the slave systems. They're called slave systems because they have to do what the central executive tells them to do, okay? So some tasks might require more visual spatial sketchpad, and other tasks require less. Right? And so the central executive determines, well, how much attention, how much fuel does the visual spatial sketchpad require in order to complete this task? So for instance, if you're reading a book, you're going to need lots of the visual spatial sketchpad. If you're reading a story and you're spontaneously creating images that are consistent with the story. But if you're watching television, there's already lots of images there. So you don't need the visual spatial sketchpad as much. Right? And so those are the sorts of decisions that the central executive will make. All right, so central executive is deploying attention. And in fact, the central executive or executive function is like short form in psychology for attention. Right? That's what it's often meant when they use that terminology. Okay, so we had some questions at the beginning of the day. How do we conceptualize memory in psychology? This is audience participation time. Recalling and using right away the information that we learned today. How do we conceptualize memory in psychology? Yes? No, you had pretty good on the details there. So one way that we think about memory is with a computer metaphor, right? That we encode the information, we store the information, and then we retrieve the information to use it, okay? But that's actually the second question. What are the different processes of memory, right? How do we conceptualize it? Yes? It's a reconstructive process, right? We have to regenerate the memory from scratch each and every time. Okay, good. How can we encode information to make it more memorable? Yes? Relate it to ourselves, right? That's one way, yep. Yes? Chunking information, good. Yes? Repetition. Okay, we didn't really talk about that, but repetition can help with knowledge and facts, yes? Yes? Mnemonics. Did you have something else to add? You're going to say that? Yes? Right, so chunking again. Pardon? Okay, and did you have your... Okay, all right. We missed a couple of really important points here. Right, depth of processing, yes? Active encoding, absolutely. Active encoding as opposed to passive encoding, yes? Well, I'm sorry, say that one more time? Right, and what is a deep level of processing? Semantic, that's right. And then we can make it even better by using the self-referent encoding, right? Yes? Right, and which one, mass versus space, and which one do we like? We like space practice, right? That's where you get the best results. Okay, so what are the three different types of memory storage? You're going to spread the opportunities around here, as many people as possible. Yes? Sure, say all three. Right, so there's sensory and then short-term / working memory, right? They're very similar in their conceptualization, and then we have long-term memory. Okay, good. And what are the different components of the working memory? So I want you to identify the component and then tell me what it does. So you just have to do one. You don't have to do all four. So last one we talked about. Oh, hang on, I already asked you. Let me just see if somebody else want to play? Yeah. Visual sketchpad, spatial visual sketchpad, right. And what does it do? That's right, manipulation of mental images. Okay, yes. Central executive, which does what? It controls all the other slave processes, that's right. And in particular, what's the important thing that it deploys? Attention, good. Okay, that's 2. We got 2 more. Yep. So the phonological loop, yeah, and what's its job?
It maintains all verbal information you've heard, and it can rehearse it so that we can remember.
Right, so it's maintaining verbal information, either spoken or read. Okay, and one last one. Yes? Episodic buffer, and what's its job? Okay, that's fine. Somebody want to help? Yes? Yeah, it creates an episodic experience. It's combining 2 things. Yeah?
Takes the auditory and the visual information and combines them to create an episode.
That's right. It's integrating auditory and visual information into a single episodic experience. Okay, so that's my time. Thank you very much, and I'll pass it back over.
Okay, who thinks we're done? Who thinks that when you finish this lecture, you have your notes, you go away, who thinks that's it for the notes? You pick them up again when you study for your exams. Good. So, first thing I want you to do is finish up your Cornell Method. If you want to write your summary on the bottom and your keywords on the left, go ahead and do that. And if you want to reorganize your concept map, I'll give you a minute to do that as well. Okay, I'll bring your attention back to the slides. What I want to encourage you to do after every single class is to create what we call a review note. A review note is not just copying your class notes into another document. It is organizing, summarizing, and condensing the notes that you took in class into a form that is very useful and easy for you to study from when you're going to be going into your exams and your tests. So you might take notes in the Cornell Method during class and create concept maps for yourself to study from for your exams. Or you might do it the other way around. Or you might want to combine all of your information into a single Word document that you can just print off and study from when you go into your exams. I want to encourage you to play around with different note-taking methods to figure out which review note method works best for you, because this is really going to help you process information and recall it when you need it for your exams. So, who has gone to study for a test or an exam and feel like they've never seen this information before in their life? Almost all of us, right? This is why. This is called the curve of forgetting. So you're going to leave here today and you've heard Paul's lecture and you remember whatever you remember. That's your 100%. That's everything that you remember from this lecture. Tomorrow, how much of that information do you think you're going to remember? Give me a guess. Yeah. 50%, I heard 85%. Any other guesses? Okay. Tomorrow, you will remember 50% of what you learned today. So literally one day later, you will have forgotten 50% of the material that you will be tested on in your exams. So, when you think about the fact that your exams are about 6 weeks from your first week of class, what do you think you're going to remember by the time you hit exam date? Yeah. 5%? Any other guesses? 2%? 3%? You're at about 2 or 3%. That's why when you go back to your notes, you feel like you've never seen this information before, because you've already forgotten it. So, to change this curve, to remember better and remember more of the information out of our lectures, we need to review regularly. And what happens is that if you review on day 2 for 10 minutes, that's it, 10 minutes you review your notes. And maybe this is the time you take to make your review note, and that's when you go over your notes again. You will return your curve to 100%. After 7 days, if you review for 5 minutes, you will again return your curve to about 100%. And so by the time you get to the 1 month mark, it only takes about 2 to 4 minutes for you to remember all of that material because you've been reviewing every single week for only about 5 to 10 minutes. Now this seems like a time investment, right? Because every week you have to go through your notes for every lecture for 5 classes. But this actually saves you time in the end because when you go to study for your midterms and exams, you don't need to relearn material because you already have it in your memory. So you only have to study, you don't have to learn, right? And the last thing I want to leave you with is Bloom's taxonomy. So this is a 6-tier model for the types of information that you're going to be asked to learn in school. In high school, you have the bottom 3 levels: remember, understand, and apply. Those are the 3 things that you're asked to do on tests. You have to remember plain information, you have to briefly understand the material, and you might be asked to apply it to a case study, for example. In university, about 70% of the material you're going to be tested on is analyze, evaluate, and create, which is not what you're tested on in high school, okay? So a lot of the material that you're going to find in university is going to be at these higher levels of learning that are more difficult to access. So analyzing means that you're able to break down information. Evaluating means you're able to judge the importance of information and assign it value. And creating is something like you would do in an essay where you would create a thesis statement or be asked to create a painting or something like that. So these are the levels of learning that you're going to be tested on in university, which is why you might find that your tests are going to get a lot harder. So keep these 6 levels of learning in mind when you're studying for your tests. I just want to say again, there are tons of resources at the Student Success Office for time management and for note-taking. So if you want more information about that, please contact us. And I'll take any of your questions, but I think we're going to wrap up quickly because we're running out of time. Yeah? That depends on your professor. So some professors will usually find a break when they see a hand. They'll find a natural break for them to take questions, but you can always go to your professors after class and you can always email them if they sort of escape you. Yeah. Yeah, so what a lot of students do is when they actually build their time management schedules, they'll build in time for review. So like after lunch on Tuesday, I'm going to review for Econ 101. And that's it. That's just 10 minutes that you need to take out of your schedule to review for that class. Other questions? Okay, so I believe you're going, oh, yeah. Okay, thank you.